Hi guys, Tom here with a lab report for this week. You guys are going to be meeting on April 6th. I'm preparing this on April 5th on Thursday because I'm taking a flight tomorrow, or this evening actually. So let me kind of outline where I've been. I prepped a little thing for Matt to work on, which will code lasers and the OK sign gesture separately. So I was fooling around with that the other day, and so that's a nice picture of that. So red dots are the OK signs. Obviously, a lot of false positives, and Matt can talk a little bit more about that. So my big goal for the week was to try to put together a pretty good representation of the whole package for a map labeling system in Python. I got most of the components in place. It's still not all there, but every kind of outstanding problem that I had has now been solved. So now it's just sort of a matter of putting it together. One of the first things I wanted to tackle was the text-to-speech. So I knew it was going to be pretty easy to do some of the map registration and pulling it down from nominatum. I didn't know how I was going to do it, but at least I had done all of that stuff on previous projects, so I was pretty confident that it was going to work out okay. What I hadn't done was text-to-speech. That was as easy as I was hoping. So there are a couple of things that'll do it. I found Pi text-to-speech X3 to be pretty good. There's a version 2 that did not work, so I would use the version 3. I did have to use pip to install it, so open a command window in Anaconda using administrator privileges, and then you can install Pi text-to-speech X3. The import statement is pretty easy, so you just import Pi text-to-speech S3. You create an engine, so engine equals Pi text-to-speech X3.init. You basically add a string to it, so in this case I will speak this text, and then you say engine run and wait, and then you're done. So this worked pretty well, pretty right out of the box. So Matt and Earle, if you're interested, give that a try. The next bit was what does it say? So this gets into how do we turn map coordinates into text that's going to be informative. So what I'd like to do is, or what I'm doing right here, is using a reverse geocoder. So there are a lot of these. I'm using the package GeoPy, which has a number of different geocoders available. So there's a Google one that I played with a little bit that didn't work out so well, which was interesting, but totally fine. And so what I went to next was nominatum, which is going to query the OSM database and return back the tags, or at least some of the tags. So essentially what I'm doing here is presupposing that the laser pointer trick has worked. I've been able to pull out image coordinates. I've been able to register them as a geographic point. And so that's kind of where I'm starting. So I'm defining some coordinates. These correspond to Davis Hall. I'm creating a geolocator using the GeoPy package. Geolocator.reverse coords is the part that actually sends my coordinates to nominatum and records back the result into a variable called location. I display that location, and then I basically feed that back in to the text-to-speech engine and then make it say it. Within Python, that looks something like this.
Davis Hall.
All right. And then I've got an object over here. So place ID is going to be where I extract out the OSM ID. And then display name is going to be sort of the piece that comes back. And then location itself looks something like that. So location is an object, and I've got a number of different things that I can pull out of that. So I can pull the latitude and longitude, a geographic point, and so on. This is an example again of what that location.raw looks like. You can see that what we're pulling down is a lot of different tags from OSM, including a bounding box, the display name, lots of other things. So this display name is actually a really long string that has commas in it. So I'm basically using a method within string to split that off. So Earle will probably recognize this. I'm taking that string and I'm splitting it wherever there's a space. And then using the very first element off of that, to pull the name out itself. The problem with that is that I'm not getting all of the information that I want. So there's a ton of stuff in here, but not everything that I actually really care about. Part of that, I think, is related to the fact that what I'm pulling in, well, we'll get into that in a minute. So what I was looking at next was pulling in stuff using Overpass. So Overpass is a second way of accessing that. So we've used Overpass Turbo in class. I've got a slide here kind of illustrating that. So Overpass Turbo, we're looking for drinking fountains, or we're looking for grocery stores, and we're pulling in all of that information. The whole thing ends up looking something like this. So we're importing, I skipped over the part where I installed this, but I had to use pip to install this, so pip install overpy. Once you do that, you can initiate an API, kind of an odd variable name here, but API equals overpy.overpass, so we're initializing our connection to the database. This is where we're sending in a query. The format of this query is a little bit odd. In this case, this is coming straight from a example that's online. What we're doing right here is we're looking for a node within this bounding box. So this is the bottom, the top, the left, and the right. So it's going to retrieve any nodes that fall within this, and then we can kind of look through. You can see that all we pulled out, we're putting that result into this variable called result. So we pulled out 1,984 nodes, no ways, no relations. So one of the things I think we can do, I haven't done this yet, but if we're using either the laser pointer or more specifically, I think the gesture recognition, we can use that bounding box as a way to limit our query. And so what I think I'd like to do is specify a bounding box related to the size of the OK symbol, and then have it tuned to look for certain kinds of objects like buildings or things of that kind. Matt, I'd like you to take a look at the Overpass API. So there's the Python API, and then you can practice doing this by just crafting URLs, and you'll kind of figure out how to do this. And I'll give you an example here in a second. But there's a web page. If you just Google Overpass API, you're gonna find this resource. As I said, for people who are not in 459, this is basically tying into the Overpass system that we've used as part of that class. We used Overpass Turbo. Overpass Turbo is just a web portal that uses this exact same interface. And so, Matt, you can start to sort of figure out how this works in relationship to some of this stuff as well. Before we get into that stuff, I want to demo that. So if we pull this open, this is where the Overpass API language guide is, if you want to fool around with that. This is Overpass Turbo. This is Davis Hall. Well, this is OSM with the map pieces turned on here. If we click on this, this is Davis Hall, and what essentially we're going to use, at least this is the framework now, is nominate him to do the actual query, and then Overpass to pull up all of the data. And I think we're going to be able to simplify that and just use Overpass. But the thing that we're interested in here is the ID, wherever that went. So this ID up here is what we're looking for. And I think we can use things like the building tag to limit our scope. So this is building, it's tagged as a university. Basically anything with the building tag set we can use. Okay, so to show you what this looks like, this is an example of what the thing. So we're creating a link to Overpass here, and then we're making a query. This query is a string. It's got to be set up in a very precise way. In this case, we're looking for way with this ID. We're asking it to be output as a JSON file. We're asking for all of the tags, and then we're printing them out. So if we run this little block of code, what we get is all of this stuff that corresponds to Davis Hall over here. So Matt, one of the things I'd like you to do is take your descriptions that you've pieced together and maybe make some revisions, but put those into the description text right here, because that's what we're going to use to announce our whatever it is we wanted to say. So if we want this to say the description, what we can do is we can make the engine say this, and then we run it.
Davis Hall is home to the geology, geography, and meteorology departments. There is an observatory on the 7th floor.
So we might have several versions of that, but and it's okay to kind of, I mean, we're not in a huge rush to get that done. We've got other things, but if you've got time to start sort of crafting those descriptions for even just a couple of buildings on campus that we can use as demonstration. So Davis Hall is a good one, maybe Altgeld, maybe Holmes Student Center, Graham Hall, because that's where Galen Kapperman is, and we can modify the text there. So Matt, that's something for you to do, is to edit the OSM descriptions for a couple of the buildings. Don't try to do all of them, but just a couple of the buildings. Okay, the last bit that I wanted to talk about was some of the mapping for the blind stuff that I did. So as I was sort of fiddling around with this, I came across this. So here's the URL. There's already some really interesting projects being done. So Matt, for your poster edits, one of the things I'd like you to do is have a section of previous work or literature review or something along those lines, where you're reviewing just a little bit about touch maps. And so what I would like you to do is kind of have just a few bullet points, not more than 5, maybe 3, where you're sort of talking about major sort of types of tactile maps for the blind that have existed already. So include Touch Mapper for sure, which we're going to use. I would say look at these other ones, but don't necessarily use them. I would talk a little bit perhaps about this microcapsular paper, which is really interesting, and I think you'll find a good piece to talk about. This is an example of where those are. So this is touchmapper.org/en. I demonstrated the use of this. It's pretty easy. So if you go to touchmapper.org, you get this web page, and basically what you can do is type in an address. So this is the address for Davis Hall. This itself is going to probably use something like a nominatum query to figure out where it is. And it only takes a second to generate these. It's pretty amazing. You get some choices about how you're going to make it. You can hide the buildings. I've got the advanced options turned on so that you can set the centimeters, you can set the scale. You can set this to print a multi-part map, which opens up that little window, which lets you move over like one tile to the left one tile. So pretty awesome ability to do that. And then you just make the map. So you say create tactile map, it goes, and within a few seconds, it pieces this thing together. So you guys, I hope, can keep assembling the thing that we've got. When you do this, you can either order a 3D print or you can print the map yourself. If you do that, you get this nice little preview here, and you can just download the file, and there you go. So pretty easy to make these things. So Matt, one other thing I'd like you to do is look for that. Look for any scientific papers that are coming out of this. You should be able to track it down from kind of the main page here. Okay, let's wrap things up. There's another thing here on mapping for the blind. You may want to look this stuff over, Matt, and see if there's anything interesting that we should be doing as we're making edits to OSM. So develop some expertise on that, so you can talk about that next week. I did a little bit of playing around with getting QR codes generated, because this is what we're going to use to register the maps. There's going to be a sticker that we place on the bottom of any of our tiles. That sticker is going to include a description, sort of a title. It's going to include an EPSG code, and it's going to include georeferencing information for each of the 4 corners. I've already kind of demonstrated this, so this can kind of just live in the map itself, or in the PowerPoint presentation, I should say. The last thing that I did, I was working on a thing where I wanted to try to get a grid value, doing zonal statistics by latitude. So summarizing the effect of latitude on whatever. And so it's kind of an interesting problem. If you guys have some good ideas for doing this, let me know. I ended up doing it in NumPy and Python, and then uploading the result. And I did a Stack Overflow. If you guys are interested in this data set, I posted it on my Google Drive. So I probably should include, I'll go back and edit this and include a link to that at the bottom here. Okay, so last week I thought I was going to be able to do a bunch of stuff. I haven't done all of it. I have done nothing with the MakerBeam drone. I need to get to this DeKalb trees project that's getting kind of urgent because I think the presentation for that is in a couple of weeks. So I'll probably be doing that tonight. I obviously have spent a good bit of time working on the laser ID system. There's still a good bit to go on that, but I think we're coming in strong to finish on time. The last bit here is finishing the research poster, so Matt got a good start on this. Matt, keep it up. Ask Earle if you have any questions about what to do there, but I'm excited to take a look at it and give you some more feedback. Think about some of this stuff and what you can include. Don't be afraid to include some technical details. That always makes things good. And I would say that top left paragraph where you're sort of talking about sort of the general gist of touch maps, you could probably get rid of that to make room for things like a bit of a literature review. Not a texty thing by any means, but just some bullet points talking about some other kinds of major tactile maps. So thanks everybody, and sorry that I'm going to miss. Looking forward to see your lab reports. See you next week.